Hey everybody, it's Mrs. Mancuso, and we are on our last week of chemistry. This is nuclear chemistry week 3, and we are going to do artificial transmutations. So artificial means not natural. So if it is natural, we started with one nucleus, and remember it decayed into 2 parts. With artificial, so this was natural. With artificial, you're going to fire something at your nucleus. So you have your nucleus, plus you fire something at it, and that causes it to break apart. So usually, like this example right here, is what we call fission. So fission means to split a nucleus, and it will break into these 2 different nuclei, and sometimes it even breaks into more than that. But what it always releases is a lot of energy. So we have been doing a lot of work as a country and really as a world looking into nuclear chemistry over the past 50 to 80 years. How can we use nuclear chemistry to produce energy in a safe way? We know that sometimes the products that we release can be damaging. So that is where it is an issue, is that some nuclear waste is very harmful. So you got to look at what is being released. There are 2 basic types. So I'm going to put fusion and fission. These are both types of artificial transmutation. Oh, so transmutation, I always change the element when I do transmutation, but naturally it just decayed. Now I'm actually firing something at it. So fusion happens when you combine 2 very light, very small nuclei. This definitely happens at the sun, happens all the time. So you could take a hydrogen and you could take another type of hydrogen that has a neutron. This one didn't have a neutron, and you just add them up. 1 and 2 makes a mass of 3, and this is 2, and this is helium. So that is a way of doing fusion, but you have to put them together, and it has to be something very small that you're putting together. Over here, fission, this is more what we think of. This is what happens in a nuclear power plant. Although both of these reactions, I'll do it at the end, but both are going to give you a lot of energy. So nuclear power plant. So here, I'm going to start with uranium. Actually, I need like a whole big screen to do this. So imagine that I'm doing, okay, I'm going to write split, but I need a new screen because I need more space. Okay, uranium 2, 3, 5, and uranium is element 92. Let's say I fire a neutron at it. That's a neutron. What happens is it splits into 2 nuclei. So one of them is 142 barium, and barium is element 56, plus I'm going to show you how you solve for the other nuclei, and you end up getting 3 neutrons as a result of it. So in order to figure out what this is, let's just call it X. In order to figure out X, you have to do the math. So over here on this side, let me use a different color. 235 and 1 is 236. So I need this and this and this to all add up to 236. So I have 3 1s, so this is 3, and this is my X, and this is 142. So if I take 236 minus 142 minus 3, I get 91. So this top number has to be 91. And then I'm going to do it for the bottom, 92. So I need 56 and X, and 3 zeros is just 0. So 0, X, and 56 have to all add up to 92. So 92 minus 56 gives me 36. So this has to be 36. So I go like this, 91, 36, and now I just look up what element 36 is, and that's krypton. Kr. So that's how I find out what it broke into. So a lot of questions ask you to solve for X. And my big thing is make sure if you have 3 of these, that means you have 3 ones. So that way that's why I put a 3 there. Okay, so this was splitting. This was fission. So I could take this, I fired a neutron at it, and I made barium and krypton. I broke it into 2 different nuclei. So that's why it was fission. That's why it was splitting. Now, the next part of this is that both of these reactions, so both fission and fusion, both produce a massive amount of energy. They are big energy producers, but they lose a very small amount of mass in the process. So if you lose a little tiny bit of mass, now when I'm talking about a little bit of tiny mass, I'm talking about way over here to this decimal place. It's not something that we notice when we balance, because when we balance reactions, we're just looking at this first number, so we would never notice this little bit of loss of mass. But that little tiny loss of mass causes a big change in energy. All right. So that's really it for artificial fusion, fission, the changes in energy, and you got to fire something at it for it to be artificial. All right, hope you enjoy this last week of chem and your last work in chemistry. Let me know if you have any questions.